Okay, hey everybody, this is question number 7 out of page 261 in our textbook, and it tells us that the uniform plate has a weight of 500 pounds and that it wants us to determine the tension in each of the supporting cables. So we've got 3 tensions, B, C, and A. We've got a 200-pound force that's acting down on the plate as well, and then it also has a weight of 500 pounds. So we're going to incorporate all that into our free body diagram. Got our weight. Got our force of 200 pounds, all 3 of our tensions. So there's our free body diagram, and this is also a 3-dimensional problem in the X, Y, and Z, so we're going to have to account for that as we go along. So the next step is we need to do the sum of all our forces and components so that we can do system of equations after that. So first, I did the sum of the components in the Z, because we know that all is going to have to. We know that since all our forces act in the Z, we can sum that the easiest. So the tension A, the tension C, and the B subtracted from our 2 downward forces are force of 200 pounds and our weight of 500 pounds. So the tension A, C, and B all have to add up in the end to 700 pounds. So that's an easy way for us to check our work later. So now we're going to do the sum of our moments so that we can find 2 more equations and then do a system of equations. So we're going to do the sum of our moments along the x-axis first, and that's assuming a positive counterclockwise rotation. So we're going to have our distance from our tension A from the x, which was 3 meters up here, and then our tension C, which is right here, is also 3 meters. Tension B is 0, so that's 0. That's feet. It's all feet, not in meters. And then our 200-pound force is 3 feet from the x-axis, and our 500-pound force is 1.5 feet from the x-axis. So that's going to come out to 3 feet times the tension in A, 3 plus 3 feet times the tension C is equal to 1,300 pound-foot of force. So that's our second equation. And now we need to find our third, and then we can do our system equations. So next we're going to do the sum of the moments in the y-axis. So from the y-axis, assuming positive rotation. So tension A, since it's right on with the y-axis, it's going to be 0. Tension B is 4 feet from the y-axis, as well as tension C. And then the 200-pound force is 2 feet from it, and the 500-pound is 2 feet from it also. Set those all equal to 0. So it comes out to be 4 foot tension B plus 4 foot tension C is equal to 1,400 pounds. And now that we have all 3 of these equations, we can do our system of equations and solve for each individual tension force. We need to solve for these, using these 3 equations, solve for all of our tensions. So we're going to do this by using this base equation and changing it to give us only one of the variables set equal to a value on each one. First, we're going to find the tension A by taking tension A, tension B, tension C set equal to 700, multiplying it by -4. So our tension B's and C's will cancel out. And so that will leave us with a -4 times the tension A is equal to -1,400 pounds. So that's -1,400 pounds. And the 4 is a foot, so it'll cancel out when you divide. So your tension A should be 350 pounds. We're going to do a similar thing on the next one, except this time just using -3. So TAs will cancel out, the TCs will cancel out. That'll leave us with -3 TB is equal to -750 pounds. So tension B is equal to finally 250 pounds. And now, using these 2, we can sum up using our other equation to find. Set them equal to 700 to find our tension Z. So TA plus TB plus TC has to equal 700. Since we know 350 and 250, we know that our tension C must be 100 pounds to make 700 pounds. So that's just a simple way to how to solve these equations using some of the forces and moments to find our tensions for this question. Thanks.